Hello friends, today I'm going to solve LeetCode problem number 71, simplify path. In this problem, we are given an absolute path. So absolute path means the path starts from the root directory and it is a unique style file system path and we need to convert it into a simplified canonical path. So in unique style file system path, we could have a period which refers to the current directory that we are in. We could also have double period which would refer to the directory up a level, and we could have multiple consecutive slashes that would just mean that would just mean or that is treated as a single slash. So we could also have three periods, and three periods are treated just like file directories. And in a canonical path, the path always starts with a slash, and two directories are separated by just a single slash. And the path doesn't end with a trailing slash. And one more thing is that the path only contains the directories on the path from the root to the target directory. That is, there is no period, no double period. So we need to convert the unique style to canonical style. Okay, let me give you an example here so that you are able to understand it more clearly. So let's start from our root directory. So unique style, that is absolute path, starts from unique directory, right? So from root directory we could have like multiple slashes between any two directories. So documents, let us have a document directory, and then we could have like slash and double slash. That would mean that we are going back to directory one level, and then we could have like slash and another directory. Let us suppose that it is desktop directory, and then slash dot slash dot still means that we are at desktop directory. And then like we could have multiple slashes, as many slashes as you want. And then if we have three dots, that would mean that we have a directory or a file named three dots, and then we could have some file or something like that. So this is our unique style directory path, and now we need to convert it into canonical. So canonical, it starts with a slash, so we will have slash to name of the directory, and since these are two slashes, that is always treated as a single slash. And then after that we have documents, right? So document directory, and then what do we get is a double dot slash, right? So double dot slash means that we are going one directory up, right? So that is, we are going one directory up from document, so we've reached root. So what we did is we removed the directory just before that, and then we are now adding our desktop directory here. And then we have a dot is treated as the current directory, so we are not changing anything because our current directory is desktop. And then slashes are treated as a single slash, so we are not changing anything so far. And then we have triple dot slash, so this is also treated as a file or directory. And then we have the last file name or a directory name, which is equals to file. So this is our canonical path. And if you observed clearly, what I was doing was that when I encountered this double dot slash, I removed the last element, right, the last directory from our canonical path. So in what data structure can we remove the last element? Well, it is stack, right? In stack, we could perform a last in first out operation, right? So what happened was, I had my root directory, and then here I'm creating a stack, and then I had the document directory, and then I encountered a double dot slash. So in that case, I removed the top of the stack, so I pop it off, and then next I encountered desktop. So now I push to my stack desktop, and then since it is a dot, it doesn't matter, and multiple slash also doesn't matter, we are not going to do anything. And then we encountered three dots, so now we are going to push three dots because that also represent a file or a directory name. And then finally we found our file, so we push these all in our stack. And then at the end, what are we going to do is we are going to join all of these items using a slash. So when we join these, we'll have root slash desktop slash double triple dot slash file. And we know that canonical path starts with a slash, right? So after joining this, we are going to add concatenate or slash at the beginning of the resulting string, and that will be our result. So to solve this problem, we are actually going to convert this whole Unix path to a array using a split operation. So we are going to perform split over slash. All right, and then we are going to create our stack, and then from this stack we are going to get our result. Now let's solve our problem. So let us just look for the base case. Path should be from the range 1 to 3000, okay, and there are only English digits, and period slash or underscore. Well, underscore would be a part of the name of the directory or file. So and the path is a valid absolute Unix path. So let us just check if path dot length, okay, length is equals to 0. If that is the case, then we are just going to return slash, because that would mean that we are in our root directory, I guess. So you could just, in interviews, we should always ask clarifying questions if we have any confusions or like any doubt related to anything. So now let's continue. Let us create our array by splitting the path. So path split over slash, and then what are we going to do is we are just going to use filter to remove all the items that are either empty or just have one dot, because that means like that doesn't because here in this case we didn't do anything, right? So it doesn't make any difference. So we are going to use filter. Okay, let me check the filter syntax in JavaScript. So once we have split it, we will get our resulting array that would contain slash, that would contain empty items or item with a dot or the name of the directory, right? And then we are performing filter over that array, and we want to filter each item and only have items that are either not an empty array, because these mean that this is what we are actually looking for. So filter based on these conditions. So word length greater than 6 means it removes all the words that are less than the length 6, and we get word length greater than 6. So here what are we looking for? We are looking for item which are not an empty item, right? So item is not equals to empty item, or and okay, it will be on or item is not equals to a single dot. So we are going to eliminate all of these items from the array. So our resulting array will have just like triple dots or the name of the file only. or double dots. Now we are going to iterate over each of the item in our array. So for each of the item, if the item is equals to double dot, then what are we doing is we are going up one directory, right? So we actually pop out of the stack. So let us create our stack first. Else what are we going to do is we are just going to push to our stack the item, because that would mean that the item is a file or a directory. And then finally we are going to return slash concatenate it with stack and join the stack with a slash. Okay, let's try to run our code and see if it works. Okay, so I got some error here because I'm not taking care of So I believe the filter is not working. Let us try to print our array and see what happened. Yeah, so here it is. Our filter is not working, and why is that? Okay, let me just do this for a while. Okay, so it worked here. Okay, so we actually need an and condition because we are removing the item which is empty. We don't need item which is empty, and we don't need item which is a dot, right? So we are performing an and operation actually. Let's run our code now. Cool. So all our test cases passed. I have added few test cases of my own to check for like dot, double dot, and double slash, and it's working. Let's submit our code. Okay, awesome. That's very good. So now let's find our time complexity and space complexity. All right. So since we are using an array and a stack, so we are actually using extra spaces, right? And this extra space depends on the path, right? So if the length of the path is n, then and let us suppose that the number of directories are equals to m, then the length of these would be o m, and yeah, our time space complexity would be o of m. And same for this, since we are performing a for loop, our time complexity would be o of m. And also we are performing a split operation, right? That also takes o of m time complexity, and join operation also takes o of m time complexity. And adding all of these together, our time complexity becomes o of m and space complexity becomes o of m. Hope you liked my solution. Let me know in the comments down below. If you have any feedback for me, let me just know that as well. And I wish you have a wonderful rest of your day. Thank you.